Good afternoon, Ms. Chairman. My ladies and gentlemen, title of my presentation is Reliability-Driven Asset Management Using HART Communication. Some words about my presentation agenda. Some words about, I would like to overview and give a picture about our company, MOL Group, and my refinery where I come from, it's Danube Refinery. Some words about the business drivers to increase the use of HART. Some words about our DCS situation and smart instrumentation in Danube Refinery. Some words about organization and system improvements, and finally our future plans. Okay, let's jump into detail. Here you can see on the map the MOL Group. We are really small comparing to the big players. The size of the logos are really correlating to the company's revenues. We are strong in the world, but we are small in the world, but strong in our region. You can see the MOL Group sales directions. This direction shows you the fuels where we sell products, LPGs, bitumens, chemical products. We have 5 refineries in Central Europe. The flagship refineries in Slovnaft, very close to Bratislava. Another one very close to Budapest, which is another flagship refinery. And we have 2 partly owned refineries in Croatia. And in 2007, we bought a refinery in north of Italy, very close to Mantova. And here you can see our product slate. We mainly deal with fuels and chemical products. Okay, some words about the business drivers. This picture shows the European refineries in order of profitability. In Europe, there are 100 refineries. Danube Refineries was the 4th most profitable company in 2008. But after the economical crisis, the refineries' margin a little bit melted, and in 2008, just 7% of the companies produced loss. In 2009, their number increased up to 35%. In 2011, the situation is even worse. Now, around 40% of the companies produce loss. Here is a list of the growing number of threats, pressures, needs, and of course as well possibilities. Seeing all these factors, we stop for a second and said to ourselves, do we want to run from these threats, pressures, needs, and demands? Or do we want to gain such an advance that allows us to soberly interpret these internal and external drivers as guidelines to determine the path that we want to pave and follow? We voted for the second scenario and decided to fully exploit our existing technologies, such as HART communication. Okay, all right. What does full exploitation of HART means in the reality? So we looked around in Danube Refinery and found that MOL has 58 units in the Danube Refinery, 95% of them equipped with DCS and safety PLCs. You can see here. You can see here as well the distribution of our DCS vendors. We have we use various type of DCS from Emerson, RS3 and Delta V, from Honeywell, TDC and Experion, and as well we use Yokogawa DCS Centum 3000. And we analyzed the situation at the field of field instrumentation. Only in the Danube Refinery, we have around 40,000 field instrumentation, including the transmitters and the control valves. And 75% of them are HART ready. So both of them are enabled very good situation, very good foundation for us to exploit the HART technology. Okay. Some words about our computerized maintenance management integration. Here you can see our pyramid, which is such a massive like the Egypt pyramid. The first step was to develop a maintenance and automation development strategy in order to integrate our system at various levels. First is the equipment level, control system level, expert and diagnostic system level, and above them the integration level, which is not filled at the moment. And on the top, we have our CMMS systems, which gathering all the information, gathering and processing all the information from the expert and diagnostic solution. Our motto is, in our maintenance strategy, more predictive and proactive and less reactive type of maintenance. For this job at the field instrumentation, we used to have field instrument, of course PLCs, expert and diagnostic systems, condition monitoring, SAPs. We have refinery-wide information system with different levels for control network and business network. And we asked many times, but what can a handful person do when you are planning to take part in an elegant ball? You can only work them if you assemble or integrate them into a wonderful necklace. And this is what we did with all these pairs. We did integration into a really big, massive system. But how is this integrated beauty shiny when in use? Let me explain it with an example. Say one of us control valves gets stuck. So we can control it only in a opening direction, but in the closing direction it's faltering. If we have intelligent positioner on the control valves, it immediately sends preventive information, preventive signal to the DCS, and the signal goes toward to the field instrumentation management system. It's integrated in a central AMS or PRM system. We have dedicated staff to analyze it is a critical event or not. We send to the system only the real critical alarms. We filter out the less critical alarms. We don't want to overload the system with only low critical events. Here you can see a table. Here is the text. It's like a P&ID text, and this is a cross-reference table between the P&DCS word and the SCP-PM word. And if it is a high criticality alarm, it will go toward to the or SCP-PM, and we can analyze this alarm using the risk assessment. Here is a people who decided if it is based on the risk-based work selection, it's real critical or not. Thank God, the decision making is very easy, because around 99% of all the automatic notification from the system, we found it well grounded and can be readily accepted. Here you can see the benefits from the predictive notification, and up $7,000 up to $7,000 up to $700,000 we can save on avoiding unit outages. While the previous slide was about routine maintenance, this one shows you a practice in turnarounds. Here you can see some units, and the blue bar shows you the control valves in these different units. But using this system, before the turnarounds, we analyze the health of the control valves, and during the turnarounds, we only remove the small portion of the control valves, saving a huge amount of money. 10 years ago, we removed all the control valves, because we don't know nothing about this status, their health. Depending on the unit size and how much control valves we remove during the turnarounds, we can save $20,000 up to $70,000 only on control valve maintenance during these turnarounds. Here you can see two cases. Case one, maintenance cost without diagnostic. Without diagnostic, we can do many crane jobs. We can pay for valve technicians, repairing, testing. We can do many mechanic job, remove, disassemble, reassemble the control valves. But if you see the case two, using HART diagnostic before the turnaround, we pay for a diagnostic expert, but we can dramatically reduce these very costly factors. All in all, the implementation of the integrated HART-based system, in our case, paid back within about 2 years. Some people say this is one of the sexy systems that doesn't give us too much benefits. They are. If you fail to understand their usefulness and to exploit, exploit the opportunities hidden in them. What benefits would be missed without using this system? For example, we will miss the on-time information to reduce risk of failure, insight into the technical condition of the equipment items, especially the control valves, prevention of emergency shutdowns, and this system gives us a systemized framework for arranging our daily routines. Because we believe the preventive information from HART is same to a maintainer as alarm to an operator. Can you imagine a process unit without alarms? It can only either operate or shut down without warning. How would that make you feel? Would you be comfortable or happy? We didn't like that feeling, and this is why we opted for the flexibility that HART can give us. As a last comment for a lesson learned slide, if you have an instrument like a piano, I think you can easily learn and quickly learn a children's song. But this is not why your piano have. This instrument can do much more than that. And over years, we discovered we can also develop and learn how to play some more really heartful music. Finally, I'd like to sum up our future plans. For our future plans, a new paradigm will be implemented. We intend to roll out HART technology to the entire life cycle of our assets, simply because we know the system is capable of following the equipment from the cradle to the grave. The installation test commissioning is absolutely obvious to doing the loop checks, the site acceptance test using this system. The calibration reports, especially the paperless calibration reports, that's one of the elements what we really use. Of course, we use the preventive and predictive diagnostic in our daily life. We would like to extend, so all the repair reports should be into this system. And finally, of course, the decommissioning. We want to follow the integration of all key units into the online AMS and PRM system. We decided to increase the use of wireless HART transmitters for diagnostic and for monitoring, especially for heat exchanger efficiency monitoring. And last but not least, we decided to train our people to make them be in such a good shape as our system is. Thank you very much for your honoring attention.